Yeah, that article was part of the Continuum series, which is another AAN publication that really does a great job of providing the latest and greatest. And every 3 years, certain standard topics, things like sleep, come around again. And so that was our chance again to update the field on what sleep is really thinking about and how it relates to neurologic health and neurologic disease. And so, we've had some revelations, out of many excellent labs, including those of Dr. Saper and Dr. Fuller and Dr. Scammell. And so what we found is that our understanding of sleep-wake neurophysiology and neurocircuitry has actually gotten a little bit fresher and a little bit more elucidated. And so what we found, or what they found actually, was that it wasn't just the monoamines, these wake-promoting neurotransmitters that really drive wake and sleep regulation, but it seems to be they're moderators or modulators of an underlying fast neurotransmission backbone. So we're talking about things like glutamate for wake and then GABA for sleep predominantly. And so these external systems, which used to be the primary drivers of the sleep-wake switch that we were looking at, but didn't quite do what we expected. You knock one out and the animal still stays awake. You increase it and maybe there's an increase in wakefulness to a minor degree, but now you found this new system, this glutamatergic system or the GABAergic system. You knock those things out and you get much more dramatic changes in sleep-wake. And so it seems that's really the backbone, that all of these other systems, intentionally redundant, but also important for different functions, right? So motivation potentially through dopamine pathways could be, we don't exactly know what the serotonin pathways are doing, and how those are regulating this underlying sleep-wake architecture. And so it seems like that's really the biggest update that we had to the field in the interim since the last Continuum. And then you start thinking about that, well, okay, we're learning more about sleep and wake, and that's great from a physiologic understanding, an understanding of disease processes, and an understanding of how you can actually influence the sleep-wake system from a therapeutic standpoint. But then we're also trying to fit this into still the ultimate question that was really hinted at and that we've all known, but hinted at by Dr. Rechtschaffen's statement that, and I'm not going to quote it exactly, but that it was, I think I put it in the article actually, but that if sleep didn't subserve some absolutely essential function, it's the biggest mistake evolution ever made, right? So in essence, we're spending a third of our life in this high risk situation. Now that we're in homes, it's not the same as when we were sleeping in caves or out on the plains, but it clearly is important. And we haven't really nailed down the whys, right? Many reasons why we actually have to sleep and how essential that is to body and brain health. You can certainly see it in sleep deprivation experiments that were done in Dr. Rechtschaffen's labs and I think Dr. Kleitman's lab, where you can see the physiologic effects and actual physical effects of sleep deprivation. But from the standpoint of the brain, we're still trying to understand that. And as I said, Dr. Holtzman and many of his trainees who are now going on to their own illustrious careers are the people who are looking into these questions. And we're, looking at it in animal models, translational models, in indirect evidence from how, you treat patients with obstructive sleep apnea, what factors about that are actually influencing their brain health. And so looking at that, you kind of get this sense of a model that's this, it can either be a vicious cycle or a virtuous cycle. And it's these aspects of, sleep adequacy. Are you getting enough sleep again? Then it also relates to the intrinsic biorhythm or the alignments of these sleep drives, the homeostatic drive, and predominantly the circadian rhythms, because circadian rhythms dictate immune function, oxidative stress, and how your body manages that, inflammation. All of these aspects are regulated by these internal clocks. And so all these things need to be harmonized and working well to be able to actually get the restorative functions of sleep. And adding into that is the knowledge of this lymphatic system that helps clear out toxic proteins, things like amyloid, alpha-synuclein, tau, that are naturally produced by normal amounts of wakefulness. Neurons firing create these things. It's part of their job. It's part of the byproduct of actual brain activity. And so we have to sleep to clear those things out. But if you don't sleep well, whatever that means from a quality or duration standpoint, then that can influence whether or not, and also doing it at the right time where the system is primed for doing what it's supposed to do. If you're trying to, if you just put people on misalignment of their circadian rhythms, they won't mount the appropriate vaccine response, for example, or they could be more susceptible to illness. So it's really putting all of these different factors in to an optimal sleep package that then helps the brain do its restorative function overnight, then preventing the insult or the damage to neurons. But if you have that damage, then it breaks down these biorhythms and it breaks down all these alignments, and then it then feeds back into the cycle. And so the goal is to say, well, are there factors that we can influence in this that can stop that process, right? There are some things that are, intrinsic and we can't change it. You can't not get older. But there are other things that you can influence, maybe on behaviors or what have you, that can maybe break the cycle or even push it back into a more, virtuous cycle rather than that vicious cycle. But it's still, I think we're still fairly far away from a full understanding of what's going on there, even though there are great papers that are now starting to consolidate this, like that one paper in Science in 2019, but where they showed that they actually had that real-time MRI data showing the pulsations and linked it to EEG and showed how the oscillations of sleep and wake, or not sleep and wake, but sleep stages ultimately resulted in the kind of the washing of the brain. So that's just like one piece of really taking a whole bunch of evidence and consolidating into a very cohesive story. But we don't fully understand exactly how all of this is coordinated, which direction that chicken or egg story really goes, as Dr. Yoel Ju talks about quite a bit. And so it's really an understanding of, can it be a biomarker, and can it be something that we can act on early enough to actually prevent progression, or at least slow progression, because that's really all we have in the neurodegenerative world these days. And I know there are some explorations as to the role and relationship of hypocretin or orexin, which is that molecule that was discovered in the 80s or so in relation to narcolepsy. And I know that antagonists that are on the market today as sleep medications are being explored in their utility in neurodegenerative disease. But, we have a great population of people who have no hypocretin to see what their neurodegenerative outcomes are. And these are people with type 1 narcolepsy. And so I think we're still trying to hone in on whether or not that's a good therapeutic target. And also, what is quality sleep? How do we define that? We know what it is when it's really bad, but do we know what it is to optimize it and to get it back on track? And what ways you can do that, either behaviorally or even pharmacologically if you need to. So I think those are the open questions that we're really trying to sort out.